All right, Math 20s, as we head into Chapter 8, we're going to be solving systems of equations. Now, you've done some of this in Math 10, where the equations were both linear. So this would be an example that would come straight out of one of the last chapters in Math 10, where you have two equations. Truth is, if you had one equation like that, you wouldn't be able to solve it. Infinitely many things could be true for x and y, and the same thing for having a single equation with two unknowns. But when you have two equations and two unknowns, it can be solved. And the truth is, you learned how to solve it three different ways. You learned how to solve it graphically, by substitution, and by elimination. To keep this video a little shorter, I'm not going to do all three ways right now. Graphically would mean solving each of these for y equals, so that I'd have to do a little bit of juggling around to make them y equals, graphing them both on a calculator or by hand, and then seeing where the two lines intersect. And you'd get an x and a y coordinate, and those would be the answers for what x and y have to be in these equations. The first algebraic method is by substitution, the second by elimination. So let's do this by substitution. Substitution means you're going to solve for one of the variables in one of the equations. So whichever one of those looks easier to solve for x or y. The top one looks like it'd be a bit of work, so I'd have to not only move one of the variables over, but then also divide by the coefficient. The bottom one a little bit easier, because to solve for x, all I have to do is add y to the other side, and I have x equals y minus 5. Now, the next step in this is to take that and replace it into the other equation and then solve it. So what I mean by that is I'm going to take that x equals y minus 5 and I'm going to stick it in to replace the x in the other equation. So now I have 5 times that plus 3y equals 31. And now notice this is something that can be solved. This is an equation that has only one variable, one unknown, so I can get rid of the brackets, I can move the numbers to the other side, and then I can divide by 8, and I get that y equals 7. Now once you solve one of them, the question falls apart, because basically if you take this y equals 7 and stick it into any of the equations we had before with x's and y's into them, you can get x. The simplest would be this one. Since x has to equal y minus 5, x must equal 7 minus 5, which makes it 2. Always a good idea to go back to the very beginning and say, okay, does that actually solve this equation? Does 5 times 2 plus 3 times 7 equal 31? And I think you'll find that 10 plus 21 is 31. And does 2 minus 7 equal negative 5? And you'll find that that's true as well. So there's a solving by substitution example straight out of Math 10.